Good morning. Welcome back to CompSci.rocks, another video to help you get ready for the upcoming AP exam. This time we're going to talk about array lists, and specifically the remove method, and a really common point of confusion and something you'll almost certainly see in May. We're going to work through a couple of different ways to get you past that confusion. So let's start with this list we're going to be working with over the next few slides. What we want to do is write a snippet that will remove all of the ones from this list. And most of us will probably type out something pretty similar. We'll do a for loop that'll go through each element, check each element to see if it's a 1, and if it is, remove it. We do need to use either a for or a while loop here. A for each loop wouldn't work since we're potentially changing the size of our list. Looks perfectly logical, and let's walk through it to see what happens to our list. We're going to check the index 0. It's a 1, so we remove it. Everything to the right shifts left, and our list is 1 shorter. Because I incremented, the next element we check is the 7. The 4 never gets checked because it slid into spot 0 at the same time that I incremented to 1. Some of y'all are probably starting to see the issue here. 7 doesn't equal 1, so we just move on. Same with the 2. And then we come to another 1, so we remove it, and everything shifts over. Next we check index 4, the 6. The 9 never gets looked at for the same reason we never looked at the 4. And then we check the 2, and we've looked at the entire list, and all the ones are gone. We got the right result, but we didn't look at everything, and that can cause a pretty big snag. This is a time if I was in a classroom where I'd pause and ask the students if anybody could think of a time where skipping elements might cause us to get the wrong list. So it's not a bad time for you to pause this video and see if you can think of an example list where this code would fail. And for those that paused, welcome back. Let's change the list up a little bit and see what changes. What we've done is we've switched the first 2 and the 1. Let's run through the code again and see what happens. Starts out the same way. We look at each element and decide if we want to remove it. The 2, the 4, the 7. None of those we want to remove. And then we get to our first 1. The 1 goes away. Everything on the right shifts left. But here's the snag. The second 1 never gets looked at. The next value that gets checked is the 9. So that second 1 does not get removed. And then we go on to the end. Check the 6, check the 2, and they get left alone. We're done, but we didn't remove all the 1s this time. Few ways to fix this. The way I prefer is to go backwards through the list of removing. Our if statement stays the same. And we're going to start at the last element and work our way left. Check the 2, check the 6, check the 9. We get to the first 1, and it goes away, shifting everything from the right over to the left. But because we're working backwards, the next number checked is the 1 at index 3, and it goes away. And then the 7, and then the 4, and then the 2. And this time, all the 1s are gone, and we did get the right result. Let's shrink our code a bit and move it over so we have room to look at a couple other options if going backwards isn't your thing. First, we can go back to the loop we started with and didn't check every value. But we're going to add a line where I decrements every time that we remove an element. That shifts the position back a spot so that when it increments at the end of the loop, it's in the right spot. And another option is a while loop, where an if-else will either remove the element or increments our counter, but never both, so everything stays in the right spot as our code goes through the list. And with that, we're at the end of another video. Thanks for stopping by, and be sure to check out our other videos, and good luck with you as you get ready to take your AP exam this May.